Hi friends, this is Unit R, Day 6. We're going to be working with radicals and rational exponents. Simplifying each radical expression. We're on example 2. It's marked over here off to the side. Hopefully you have the new updated notes with that as well. If I simplify the cubed root of negative 125, that is going to be a negative 5. And then now jumping into 16, now we're starting to get to things where it's a little bit more complex, because in this part I have a negative sign out in front. So that's going to actually carry to the very end. And then I'm going to go ahead and do the fourth root of 16, and then also the fourth root of x to the 20th, just so we can see what's going on. This is an even root, so we need to keep that in mind for the variable part. But the negative, here the fourth root of 16, that's going to be negative 2. And then this part, we're going to have the absolute value of x to the 5th. And the reason how I got that actually involves me recognizing this as a fraction, rational exponent, because this is the same as x to the 20 divided by 4, and we can simplify that. So 20 divided by 4 is absolute value of x to the 5th. So keep that in mind. Again, that's because it's an even radicand. Number 17, the fourth root of negative 81. This is a non-real answer. You could say that, or you could also say no real roots. It means the same thing. 18. So now we're taking the cubed root of a numerator and cubed root of a denominator. So really what I want to do is I'm going to take the cubed root of each of these separately. So I'm going to take the cubed root of 8w cubed in the numerator and the cubed root of 27 in the denominator. We can also split up 8w cubed further. So in the numerator I have 2w. In the denominator I have 3. So I have 2w over 3. All of these are odd roots, so I don't need to worry about my absolute value. And then now 27 to the 2/3 power. So there's a few ways to think about this. Again, go whichever path is easiest for you. I see that 27 is a perfect cube, and because it's a perfect cube and I have a cube here, I'm actually going to convert it to that first. So if I take 3 cubed, that's what gives me 27, and all of that is raised to the 2/3 power. So I can think about this also as multiplying my exponents. So this is going to be 3 to the 6/3, using my properties of exponents. And 6/3 is the same as squared, so 3 squared, and 3 squared is 9. Just realized I haven't been boxing my answers on these. I apologize. Now we're getting into steps that are lengthy and more involved. For the next one, 20, I have negative 8 to the 4/3 power. I could rewrite negative 8 as negative 2 cubed. I'm going to go ahead and do that. So this is the same as negative 2 quantity cubed. And then all of that is raised to the 4/3 power. So I'm going to use brackets for my other grouping symbols here. I need to make sure I keep that negative 2 in parentheses to show that it's negative 2 quantity cubed, not the other way around. When you have a power to a power, you multiply. So this is going to be negative 2 to the 12/3, which reduces, cancels down to just 4. And then negative 2 to the 4th power, if I take quantity negative 2 to the 4th power, what I end up with is 16. Over the next one, for 21, getting a little bit dicey. Now we have 4 times x to the 6th divided by 9, all raised to the 5/2 power. Again, I can see that the denominator here is halves, too, and then each of these could be squared. So what I'm going to do is I'm going to say, okay, I've got, in each of these, I could take 2 squared, x to the 3rd squared, and then 3 squared. So all of these are squared, and then that's all raised to the 5/2 power. Again, what I'm going to end up doing is canceling out these, because if I multiply through 10, 2 times 5 is 10, 10 divided by 2 is 5, so I get 5. So that's what's left here, is just each of these raised to the 5th power. So if I raise each of these to the 5th power, 2 to the 5th power, 2 to the 5th power is 32. X to the 3rd raised to the 5th power is x to the 15th. And then 3 to the 5th power, I don't know that one off the top of my head. I'm disappointed in myself. 3 to the 5th power. 243. I apologize. All right, one thing to note is that because we had an even denominator here, that x to the 15th needs an absolute value as well. So this is 21. 22, negative, and then 49 to the 3/2 power. So Again, careful, this one does not have the parentheses around the negative part like we did in 20. So because of that, when we go through and do this, I'm going to have a negative symbol out in front, and then 7 squared, that's the same as 49, raised to the 3/2 power. Again, when you simplify this, 2 times 3 is 6. 6 divided by 2 is 3, so we have negative 7 cubed. And then 7 cubed is 343, so I have negative 343. 23, we have, in parentheses, negative 49 to the 3/2 power. When we take negative 49 to the 3/2 power, what I want you to note is that this is a negative here, and then an even exponent. So this is, again, no real roots. Because negative number, even exponent. Even denominator exponent. 24, we have negative 8 to the 2/3. I can rewrite negative 8 as negative 2 cubed. And if that's raised to the 2/3, then I can simplify. So I have negative 2 in parentheses squared. So that gives me 4. And then here now I have negative 8 to the negative 2/3 power. A lot of students mess up on this because we've been talking about negatives here. They forget what a negative in the exponent means. Remember, a negative in the exponent means that we take the reciprocal of this. So if we take the reciprocal, we're going to have negative 1 over 8 to the positive 2/3 power. This is where a lot of students mess up. 8 to the 2/3 power, again, I can rewrite that. So I have negative 1 over 2 cubed to the 2/3 power. So this, I have 6 divided by 3, so I have negative 1 over 2 squared, and then 2 squared is 4, so we end up with negative 1/4. Show me the next video as I go over example 3.